Okay, so we'll get started here. So yeah, once again, this is our tutorial for week 12 for POLI 399. This is the live lab recording for Tuesday, March 31st. And we'll be working off of the 2015 CES for tutorials dataset, which you can find in the lab materials section of the content section in D2L for this course. So once again, just go to content, and then under content, you can go to lab material, and it's this 2015 CES for tutorials dataset. That's what we're going to be working on. CES simply stands for the Canadian Election Study. So this was the survey of voters done after the 2015 Canadian federal election. I know that's a bit dated now, but the 2019 study hasn't been released yet. So next year's class can play with that data set. So we'll start off just by going through some theoretical stuff here, just to review what you've already done in class, right? And so, you know, multiple regression is really a way for us to test the relationship between many independent variables and a dependent variable of interest. So I've given you the sample problem here. What explains individuals' left-right ideological identity, right? So the idea is that, you know, voters, individuals, citizens, often think of themselves, they think of, you know, we think of politics in left-right terms, you know, right being associated with conservatism, left being associated with, you know, progressivism or liberalism or socialism, choose which term you want there, but the opposite of conservatism. And this is in an abstract and a symbolic way, right? So it's not necessarily tied to policy positions or values, but it can be. So, you know, we know politics sort of has this left-right dynamic, and individuals place themselves on this left-right spectrum. So the research question here is, what explains individuals' left-right ideological identity? So our dependent variable is this variable called ideology, which is a variable that ranges from 0 to 10, where 0 means left, and 10 means right. So somebody who is, you know, rates themselves a 0 out of 10 on the ideology scale would probably be very, very left-wing, and somebody who rates themselves 10 out of 10 on the ideology scale would be very, very right-wing, and somebody who says they're about a 5 would be in the middle. And there are several variables which might explain where somebody places themselves on the political spectrum, right? So on the left side here, I have some demographic variables, some personal characteristics, right? Gender, whether somebody's a man or a woman. You know, research has shown that women tend to be to the left of men, so we can test for that, right? Age, you know, there's that old adage: if you're not a liberal when you're young, you have no heart. If you're not a conservative when you're old, you have no brain. And certainly, the research has shown that there is a relationship between age and ideology, though it's unclear if it's an age cohort thing or if it's a life cycle thing. Education. So this is a nominal variable that starts at 1, goes up to 4, and corresponds to higher levels of completed formal education. We know that those with higher levels of education tend to be more left-leaning than those with lower levels of education. We don't quite know what the mechanism is, but that is a documented empirical finding. And income, which there's some conflicting evidence there, right? You know, there's some studies which suggest that those with higher incomes tend to be more right-wing because they support lower levels of taxation. On the other hand, you know, we have terms like champagne socialist, right? You know, to describe people who are very wealthy but support high levels of government intervention and economic redistribution, presumably because they can afford it. So income is this variable where it's just the annual household income, but in tens of thousands of dollars. So if you think back to Dr. Tuxhorn's lecture, it's important to know the units that we're dealing with, right? So income and age have readily apparent units. It's just age in years and income in tens of thousands of dollars, right? So they're continuous measures. Gender is simply binary in this situation, right? It takes the value of 0 if someone's a man, if a respondent's a man, and it takes the value of 1 if someone's a woman. Education is an ordinal value or a variable. So 1, 2, 3, 4. Now, there's some other things which might contribute to ideological identification, right? So, I put 3 here. There's economic conservatism. And in this case, we're going to operationalize economically conservative beliefs by responses to a question. The government should leave it entirely to the private sector to create jobs. And so 1 is the least conservative position, 4 is the most conservative position. And this 1 to 4 scale corresponds to strongly disagree, somewhat agree, strongly agree. Support for traditional gender roles. So this would be social conservatism. And we operationalize this through responses to the question, society would be better off if more women stayed at home. So 1 is the least conservative position and 4 is the most conservative position. So again, this corresponds respectively to strongly disagree, somewhat disagree, strongly agree, or somewhat agree, and then strongly agree. And then support for the carbon tax is a binary variable, which takes the value of 1 if someone supports the carbon tax and 0 if somebody opposes the carbon tax. I'm just going to change this to social conservatism here. So this is the example problem. And, it seems a little simplistic to just say that it's just all of this stuff, but this is actually very much a simplified version of a very common research design that occurs in, public opinion, political psychology, political behavior research, which is my area of expertise. And so we're going to run this in SPSS. And to do that, I'll just show you a couple of slides here. This is what we're going to do together. So to run a regression in SPSS, it's just we simply go to the menu options where it says Analyze, Regression, choose Linear Regression, and then as you'll see, there's 2 boxes, one where we replace the dependent variable and one where we replace the independent variable. So let's do that together. So again, if you haven't already, go to the lab material section of D2L and download the 2015 CES for tutorial dataset, because that's what we will be using for our tutorial today. So I've already downloaded it here, and we're going to start off by analyzing a simple bivariate regression with ideology as the dependent and gender as the independent variable. So let's go to Analyze, Descriptive, Regression. I'm still in last week mode here. And then Linear. So again, that's Analyze, Regression, Linear Regression. So you'll see I've been doing some analyses here already. So what you want is you want to find ideology. And when you open it, you'll see these variable labels, which is simply the label field in SPSS. Personally, I like to right click, or I believe it's option click for the Mac folks, and go display variable names, just because it's a little cleaner and easier to see. So I'm going to do ideology in the dependent spot. And I'm going to find gender, and we'll put that with the independent variables. And we'll just do a simple bivariate regression now, again, just to practice getting comfortable with the interface and doing some basic interpretation. And so we get this, we get a series of outputs. And I'm just going to walk you through sort of what the program has spit out here. So at the very top, if you want to get into programming your analyses with SPSS, this is literally the commands that the program has run. And so below that, you see it says regression, variables entered or removed. So this simply means what are our independent variables? And then it says the dependent variable. Where would you place yourself on the scale? 0 equals left, 10 equals right. We have the model summary, right? So here we, the statistic that's most of concern to you folks right now is the R squared value. So the R squared is 0.014, which means that the variation or that gender explains about 1.4% of the variation in ideology. So it's not a very comprehensive model, but that's okay. We'll go through this here. The ANOVA table, all of this stuff does mean stuff. It's not something that you cover in this course, but when you take more advanced level statistics and research methods, you'll get into what that means. And the coefficients. This is the main thing which we're interested in here. So here we have our unstandardized coefficients. So we have B for the constant. So this is simply the y-intercept. And we have the coefficient of gender, which is negative 0.115. And you'll be covering standard errors, t-statistics, and significance values in later classes with Dr. Tuxhorn. But you'll notice that here is the standardized coefficient, the beta value, which if you were to run a correlation analysis between gender and ideology, it is equal to the standardized regression coefficient, at least in a bivariate regression. So I'm going to switch. Keep looking at your screen here, but I'm going to switch to PowerPoint because I've copied the outputs from SPSS. So this is simply the same thing. You'll see unstandardized coefficients. B for gender equals negative 0.115. So what does this mean, right? We have some equation predicting ideology, right? Ideology is 0 to 10. And we can predict someone's ideology if we know their gender. So, the y-intercept is 5.253, and the coefficient for gender is negative 0.115. So what does this mean? So gender's coded binary, where 1 equals woman, 0 equals man. And so the predicted ideology score for women is we take our equation 5.253 minus 0.115 times the value of gender for women, which is 1. And so if you plug that into your calculator, you should get 5.138. And the predicted ideology score for men is simply we place 0 in for where gender was, which obliterates this term, and it's simply the value of the intercept, right? 5.253, right? So what does this mean in substantive terms? Well, I told you that the literature suggests that women tend to be to the left of men, and this provides some empirical confirmation for that, right? So on average, the average woman, if we know nothing else about them, we might expect the average woman to rate herself as a 5.1 on the 0 to 10 ideological scale, whereas the average man might place himself at 5.3 on the same scale. And as you'll see in class later, this is a small difference, but it is a statistically significant difference, which means that this is not something which we think has occurred by chance, or in this case there is a less than 1,000th of a chance that this occurred by chance. So it is statistically significant, but it's a very slight difference, right? So it's a difference of about 0.2 on an 11-point scale. Are there any questions about what we did there? So we'll do another one. We'll look at age. So let's go back to SPSS and we'll run another regression model. And again, we'll stick with bivariate regression just to get a little bit more practice with the statistical program. So when you go to your linear regression dialog box, again, that's an analyze, regression, linear, and you'll see gender is in the independent box still. It preserves whatever you did last. So we'll click on gender and we'll use the left arrow to move it back, and we will find age. And let's do age as a continuous variable measured in units of age. We'll move that over to the independent slot and go OK. And again, you'll see regression. We have entered age and ideology as the dependent variable, and we see that the R squared is 0.011. So again, it's not a very comprehensive model. And I'm going to switch back to PowerPoint here. You can keep looking at your screen, or you can look at what I'm putting up here. You'll see that the unstandardized coefficient for age is 0.014. So what does that mean? So our independent variable is age, measured as a continuous variable in the units of age. And so for every year that somebody gets older, they move to the right, again, positive relationship, by 0.014 units on this hypothetical 0 to 10 ideological scale. So if somebody gets older by 10 years, we'd simply move the decimal place. They move 0.1 on that same scale, right? So using this equation, and then of course, 4.112 is the y-intercept, also known as the constant. And again, just as a preview for what you're going to be learning in class subsequently, right? This is a small relationship, but it is statistically significant, right? And so what does this mean in substantive terms? Well, we can predict the average ideological score for a 20-year-old, right? So we plug in 20 for age. So the equation for predicting the average ideological score for a 20-year-old is 4.112 plus 0.014 times 20, right? And that gives you a result of 4.392. And we keep going up, right? You see for a 45-year-old, that same, we plug 45 into that equation, we get a predicted value of 4.742. And then for a 72-year-old, we get a value of 5.120, right? So this suggests that, you might think of your university classmates in undergrad, right? Many of them might, again, not knowing anything other than their age, this might be the average score. Whereas if you look to your grandparents and their friends, this might be the average score, again, not knowing anything else about them. But this does show, if you look at the predicted values, that there is a positive relationship between age and this symbolic ideological spectrum scale. Are there any questions there? We'll do one more bivariate example, and that will be, I'll just give you a sneak peek. So that will be education. And I want to do this because, gender was a binary variable, age was a continuous variable, education is a nominal variable. So again, it'll sort of help give some practice with the interpretation. So let's go back to SPSS, analyze, regression, linear, and we'll take out age and we'll put in education. And so again, just to show you, you don't need to do this, just watch my screen. Education, to remind you of the units, it's 1 equals high school or less, so no post-secondary. 2 equals some post-secondary. So this is a large category. It includes anyone who, you know, has a trade certificate, has a 1-year certificate, has a 2-year college diploma, or started university but is not finished or has not finished. 3 means they've completed a bachelor degree, and 4 means that they have completed more than a bachelor degree. So, you know, maybe they have a master's degree or a professional degree, like a law degree, a teaching degree, a medical doctor degree, or a PhD, that sort of thing. So let's run that, and this gives you this model output, and you can see again the model summary r squared 0.018. So again, not explaining a whole heck of a lot. 2% of the difference in ideology or in symbolic ideology, and here we see a negative relationship, right? Negative 0.255. I'm going to move back to PowerPoint here just because I've already done these calculations, right? So if we wanted to write out the regression equation, ideology equals our y-intercept, or our constant, which is a 5.517, minus, because it's a negative coefficient, 0.255 times the level of education, right? And so for somebody with a high school diploma, education equals 1. So the predicted value of ideology is simply 5.517 minus 0.255, which is equal to 5.262. And you can see as we sub in higher levels of education, because of that negative relationship, the predicted ideology score decreases, right? And so we can calculate sort of what this means in substantive terms, right? So if we take, you know, the most right-wing person category here, which would be those with a high school diploma, and the most left-wing category, those with a graduate degree, you know, we can sort of calculate the substantive difference, right? So 5.262 minus 4.497, right? So, you know, those with a graduate degree or higher, with more than a bachelor's degree of education, are about 3/4 of a point to the left on average, versus those with only a high school diploma, right? So we can calculate substantive effects. Now, what we're building up to, of course, is that, you know, we can look at these individual bivariate relationships, and I mean, they're sort of interesting, right? Like, you know, men are to the right of women, younger people are to the left of older folks, more educated people are to the left of younger folks. But wait a minute, there's a correlation between education and age. Obviously, if you're 18, you can't have, unless in very rare circumstances, you cannot have finished a PhD. We know there's correlations between gender and education, right? So we should control for these different things. Well, let's do a multiple regression model now, where we look at both age and education and how they're related to ideology. So let's go back to our Canadian election study data set in SPSS, and we'll run a trivariate regression, right? So getting into the elaboration model here. So go back to linear regression, and we'll do age alongside education. And so if we run that, we see, look here, right? So r squared, you know, woohoo, 0.028. We're now explaining 3% of the variation. Obviously, because, you know, it's explaining more because we have more variables in the equation. And now you see here we have coefficients for both age and education. I'm just going to switch back to PowerPoint because I've already done the math here. And so let's look at the coefficients, right? So we have the constant, right? That's 4.8. right? So that's the value of y, ideology, when age and education are equal to 0, but there is no value of 0 for education, and you obviously don't have an ideological identification when you're dead, so when you're age 0, so that's not meaningful at this point, right? But we can construct the regression equation, right? So we can predict someone's ideology based on, you know, age and the coefficient of age, based on their education and the coefficient attached to education, as well as the y-intercept, right, which is like the correction factor for the equation. And here's where what Dr. Tuxhorn has been talking about with regards to units and why it's so important, right? Because if you look at education and you only look at the unstandardized coefficients, well, it seems that like education is way, way more important. Like, look how big that coefficient is compared to age, right? You know, that's what, like, not quite 20 times as or education is not quite 20 times as big as age, right? But because age is measured in individual years and education is measured in sort of these nominal categories, it's difficult to make that comparison, right? So, you know, by standardizing them, we remove the inherent units attached to each of these variables, and we convert them to standardized scores, right? So the units of a standardized score is simply like Z scores, right? And so we see that, yes, education does have a larger standardized coefficient than age, but, you know, it's more like 1.5 times as big as age rather than 20 times as big as age. Like, you can imagine if we recoded age as decades, then this would move aside, like the decimal point would move one place to the right, and it would be 0.12. But the standardized score wouldn't change because it's standardized according to Z scores. So there's the relative, one way that you can compare the relative impact of two different variables that go into this equation. But more important than the relative impact, I think, is the substantive impact, right? And we get that by constructing the regression equation and plugging values into it, right? So let's look at a hypothetical scenario. What would be the predicted ideological identification score for a 29-year-old with a high school diploma, right? So age equals 29, high school diploma, that would mean education equals 1, right? So we plug in 29 for age and then 1 for education. And if you put that through your calculator, you should get 4.901, right? And similarly, we can predict, you know, the same 29-year-old, but, you know, maybe they have a bachelor's degree, right? So age is still 29, but for education, we plug in 3 instead of 1. And you can see that the predicted ideology score is 4.407, right? So again, age being equal, somebody with more education is going to be to the left of somebody with less education. A third scenario here, what would be the predicted ideology score for somebody who's 54 years old with a law degree, right? So law degree, this is more than a bachelor's degree. So we would code education as 4, and we plug in 54 with into the spot for age, right? So 4.8 plus 0.012 times 54 minus 0.247 times 4, right? And we get 4.46. Are there any questions about what we've covered so far? I will upload these slides because I think there's no exercise in Stats Coach for multiple regression. If you wanted to do some practice with just simple regression, you could look at Lab 8 in Stats Coach, which starts on page 83. And you know, there's some exercises there for regression. And I did post the answer key to this on D2L. So that's a good opportunity to practice. So we have a question here. Why do we not use the standardized coefficients if we are comparing? So it's not that you don't. It's just it's difficult to compare things that don't have units. So again, the question here is, why do we not use the standardized coefficients if we are comparing, right? And so you'll see this well when we look at the full model with like a ton of variables in it. That's where standardized coefficients really like come in handy, is because it allows you a quick comparison to see which variables, which independent variables have a stronger relationship with the dependent variable, right? And it's a way to sort of quickly look at everything at a glance. The difficulty with them from an interpretive perspective is that the real strength of regression is that there are units associated with it, and because there are units associated with, at least with the unstandardized coefficients, that gives us a chance to think about this in terms of substantive terms, right? And so, you know, one of the aphorisms that's sort of really popular in quantitative analysis is not to mistake statistical significance with substantive significance. And so, you know, what that means is we can find differences that are, yeah, statistically significant where the p-value is less than 0.05. But it's really when you look at, well, what does this mean sort of in the real world, right? Like, how much more conservative is a 45-year-old versus a 29-year-old, or, you know, a 54-year-old versus a 29-year-old, right? And we can sort of give substantive meaning, right? Like meaning in a material sense to these very abstract things that we're studying by using those units, right? And so, you know, the standardized coefficients are interesting and useful when you're sort of comparing the importance of different predictors in a regression model against each other. But in terms of, you know, like interpreting the results in a meaningful, like real world sense, it's difficult to say, right? Because like it was difficult to make those conclusions using the standardized coefficients alone. So like a practical case for this would be like, let's say, you know, you have a regression model predicting, you know, likelihood of voting to a particular campaign. Well, you could compare the standardized coefficients, and that'll give you, in an abstract kind of way, like, oh yeah, we know, like, you know, characteristics X, Y, and Z make it more likely for somebody to donate to a particular campaign. But, you know, campaigns have real targets in terms of the number of donations that they're trying to get, or the total value of donations they want to get, right? And so when you're constructing real life goals there, you want to look at things which have real world import, so to speak. And that's where the unstandardized coefficients really come in. And so, you know, when you get to the stage of your academic careers, or maybe your professional careers, when you have to sort of make a meaningful empirical claim about, you know, how some relationship manifests in the real world and what the material effects of those are, it's really the unstandardized coefficients that tell you that, more so than the standardized coefficients, which really just allow you to compare relative importance. They don't allow you to predict sort of meaningful values of your dependent variable using your independent variables. But that's a really good question. Yeah, certainly if you have another question, please feel free to type it in the chat to me, either privately or publicly. we'll go to another example here, and this is actually sort of addresses some of that here. So the next example that I have here are policy positions, right? And so, you know, I said that 3 of the political orientations that might have bearing on ideological identification are economic conservatism, social conservatism, and support for a carbon tax. So we're going to operationalize the 2 abstract ones, so economic and social values, using 2 questions, right? So economic conservatism is this question: the government should leave it entirely to the private sector to create jobs. It's coded from 1 to 4, with 4 being strongly agree, 1 being strongly disagree. And then social conservatism, we're going to operationalize using you know, support for traditional gender roles. Society would be better off if fewer women worked outside of the home. This is coded 4 as strongly agree, because that's the more conservative position, and 1 as strongly disagree, which is the least conservative position. And then to help stop climate change, should governments increase the taxes on gas and heating oil by 10%? So this is how we've operationalized carbon tax. And we can quibble about whether or not these are the best ways to operationalize it, but this is quantitative methods in political science, not research methods in general. So that's the other course addresses that. But let's run this model. So we have these variables in our data set: women at home, private sector jobs, and carbon tax. So let's go to analyze descriptive statistics, or sorry, I'm still in last week. Analyze, regression, linear. We'll get rid of those 2, and I'm going to select these 3 variables. I'm just going to switch back to, so you should, this is the output you should see, right? It's entered 3 variables into the equation. And you can keep looking at SPSS. I'm just going to switch to PowerPoint because I've already made some notes here for us. So we see here R squared, first thing up in the model summary, 0.184. So these 3 questions explain, you know, 18% of the variation in people's ideological identification, right? So certainly doing a hell of a lot better than our demographic models. So the next time you see a polling firm do a media release and say, oh, like, look at this demographic divide, like, you know that political orientations are much bigger explanatory factors on people's ideology than simple demographics. And so yeah, so here is the table in SPSS. This is straight copy and paste with a different color applied. And we can construct our regression equation, right? So ideology equals the y-intercept, 3.754, plus the product of the coefficient for economic conservatism, 0.504 times whatever the value is for that create jobs question. The coefficient for social conservatism, 0.235 times whatever the value for their response to the women at home question is, minus 0.964 times whatever the value for the answer to the carbon tax question is. Right, and so to sort of go back to that question from before, right? Yeah, we can use the standardized coefficients, and this tells us that, because again, these 2 questions, the economic and social values, the 2 economic and social value questions, are 1 to 4. They're Likert items, right? Strongly agree, somewhat disagree, strongly disagree. And this question is a binary, yes or no, right? And so, you know, in terms of comparing the relative importance, we can standardize responses to them, and we see that the strongest predictor seems to be, out of these 3, economic conservatism. Opinions towards a carbon tax are slightly less strong and in the opposite direction, right? Pay attention to the sign. And the social conservatism question is about half or less than half of those other two, right? So yeah, in a relative manner of speaking, our strongest predictor is economic conservatism. Our next strongest predictor, which is very close, is opinions towards a hypothetical carbon tax. Again, remember, this is 2015. This is pre-carbon tax. And our weakest predictor of this set of three is social conservatism. But if we sort of want to see what this means sort of on a substantive level, right, predicting ideology, we have to create our regression equation, and then we can do some predicted values, right? So predicted ideology score for someone who strongly agrees with both create jobs and women at home. So that's a 4 to both of these questions. And they oppose the carbon tax, which is 0 for this question, right? So this would be the most right-wing person in the sample, right? So maximum values for both of these questions, yeah, and then the minimum value for this question, which, because it's subtracted, means it's higher up on the scale, right? And so this equation would be 3.754 plus the product of 0.504 times 4 plus the product of 0.235 times 4 minus the product of 0.964 times 0, right? So this gives you a score of 6.71. I didn't do it, and I might do this before I upload it, but we could calculate the score of the most left-wing person on this scale, right? So that would be somebody who strongly disagrees with both the create jobs and the women at home question and supports the carbon tax, right? So that would be 3.754 plus bracket 0.504 times 1 plus close bracket plus open bracket 0.235 times 1 minus 0.964 times 1, close bracket. Right, so the most left-wing person, hypothetically using this this predictive model, would score 0.3 or 3.529, right? And so interesting, right? So if we go by these political orientations, right? So looking at the most right-wing and the most left-wing person, right? We can calculate a meaningful difference here, right? So the most left-wing person, hypothetically, using this model would be about a 3.529. The most right-wing person would be 6.71. So we can do 6.71 minus 3.529, right? So there's a gap, sort of this maximum gap on average of 3.181 between the most left-wing person on these three questions and the most right-wing person on these three questions. And similarly, just the second scenario that I have here, is predicted ideology score for someone who somewhat disagrees with both create jobs and women at home and supports the carbon tax, right? So, you know, some conflicting, or at least, you know, positions that are in tension with each other, right? So to disagree with leaving job creation to the private sector and disagreeing with traditional gender roles, you know, suggests a bit of a progressive position, but not sort of the most progressive position. And they support the carbon tax, and the predicted value is 4.268, which is somewhere between 6.71 and 3.181, right? Which makes sense, right? Because that position is sort of in the middle of, or that set of positions is in the middle of the two hypothetical most extreme positions that we could have here. And this is, you know, this is a good example of the caveat that this is a model which abstracts from reality, and all models are wrong, but some models are useful, right? Like this is an abstract model, and I mean, this is sort of like, I mean, yes, you could find a bunch of people who, have this set of positions or maybe this set of positions, right? And they might not all answer 6.71, right? But like we're trying to model the predicted value of ideology using the responses to these questions, right? And so, this predicted value is an average, much the same way as these predicted slope coefficients. This is the average slope coefficient between this variable and the dependent variable. So all of these things are average, and they're all subject to error and variation within the estimate. So, and this is true because if we go to SPSS and do, like, you don't need to do this. I'm just showing this to you just to sort of prove a point. We can do a frequency distribution of ideology, and actually I'm going to do it with the standard error as well, right? And so in our hypothetical model, the extremes were between 3 and 6, right? But there are people who answer very left, which is 0, and very right, which is a 10 on the scale, right? And our predicted values are less than that, right? So obviously there's going to be variation, and it's not perfect. So the point of this isn't to predict exactly, like you don't want to be able to go around and ask people what 3 questions and say, well, I think you're going to be like a 5.25 on the ideology scale. Like that's not really the point of this. The point of regression is to make an empirical claim about relationships between variables of interest that we see in the world, and to try and explain, why is it that we see this variation. So bit of a philosophical note, but I think an important one. So we're almost out of time. I'm just going to see if there's any questions left from folks that I haven't quite addressed. So if you have a question, please type it out. While you're doing that, I'm just going to show you the other slides in this deck. So here's a model with all of the demographics, and here's the full model, which has the demographic variables and the three political orientations as well, right? So you can use this. The data set, you have it now. You have sort of a reference point of what the outputs should look like. So if you want to come up with sort of practice problems for yourself, whether it's predicting certain values by creating the equation and plugging values in, comparing the relative importance of different variables. So you can see here, there's quite a range in the standardized coefficients, so you can really tell which ones are important, i.e. economic conservatism and carbon tax, which ones are sort of important, income, social conservatism, and which ones aren't very important, like age. Are there any questions? Again, the deck is online, so you can download the deck just as a bit of a reference for yourself. Well, if there are no other questions, we will leave it at that. Thank you for joining me today. I will be back Wednesday and Thursday at noon for a drop-in lab. Great opportunity to come in if you sort of want some questions, or you have some questions for me specifically on doing stuff in SPSS or interpreting a particular model output. Other than that, thank you for stopping by, and stay safe and stay healthy, everyone.